The masses in grams of plums of a certain kind have a normal distribution. I'm going to call it X. X follows a normal distribution with mean of 55, that's our parameter here, and standard deviation, variance, I should say, of 18, which means the standard deviation is the square root of 18. Find the probability that a plum chosen at random has a mass between 50 and 60. So we can put this into our calculator. It's actually then performing an integration underneath a normal distribution of the normal distribution curve. Okay, but we can just put it in. So it's going to be normal CD between 50 and 60, root 18, 55. We get 0.7614 or 0.761. And we're told that the heaviest 5% of plums are classified as extra large. Find the minimum mass of extra large plums. So I know I've got 5% of the area under my curve here. And this is my, let me call it C. This is going to be that, that cutoff value for when they become extra large plums. So what this means is I've got 95% of my area below, and we need that one for the cumulative frequency when we're using our inverse normal. So I can say that the probability that X is less than or equal to, or less than C is equal to 0.95. That is the requirement, and then we can do inverse normal and read it straight off. So it's actually stored my standard deviation and my mean. So I just need to type in 0.95. And we get 61.978, or 62.0 grams to 3 significant figures. On to part 3, which is the hardest question, I think, here, because 1 and 2, the kind of things you would have seen before, and part B. But part 3 is a bit different to usual. So the plums are packed in bags, each containing 10 randomly selected plums. Find the probability that a bag chosen at random has a total mass of less than 530 grams. So what that means is we required the average mass to be less than 53. We're adding up all of our masses and we're dividing by how many we have to get an average. And what this means is we're not going to be using the original normal distribution. We're actually going to be using the sample distribution that you normally use in your hypothesis testing. So the mean from our sample of 10 is going to follow a normal distribution with a mean of 55 again. But now when we're sort of collecting together 10 masses, they kind of maybe, there's going to be more around the peak because that's where, there's a higher chance of being picked. And you're going to end up, in fact, with a thinner normal distribution, okay, because you're unlikely to pick 10 and get an average weight of, say, 51. There's a decent chance if you just, if you're just picking one of getting it, but much less, like hardly any chance if you're picking 10, because you'd have to keep picking them at the lower end. So this is where the standard deviation actually changes. And the variance is 18 over 10, just like when you're dealing with the hypothesis testing. So our standard deviation is then root 18 over 10. And I want to find the probability that the average mass from picking 10 is less than 53. Okay, it's pretty the reason it's difficult is that it's just like not something you see a lot of in A-level maths. So just be aware of this question and make sure you understand it and be ready for more like it if this did catch you out. Okay, so back to our normal distribution. We're going to be doing normal CD again. We're going to be looking less than 53, so the lower limit's just going to be minus a big number. Then I'll go with 53. Right, now I need root 18 over 10. And then it's the same 55. And we get 0.06801. So it's about 6.8%, but let me write down 0.0680. Okay, well done if you got that. Finally, we're told about a different distribution, the masses of apples. And we know the mean, but we don't know the standard deviation. However, we do know that half of the apples have masses between 62 and 72. Okay, let's sketch this out. So then I've got 72, 62, and this is 0.5. Remember, the normal distribution is always symmetric. So what this tells us, because they're both 5 away from the mean, is that this is going to be 0.25. And so is that. So I can write down the probability that, oh, sorry, I haven't actually defined it yet. Let's call it y. Probability that y is less than 72 is going to equal 0.75 because it's the 0.25 here and the 0.5 here. Okay, so that's all well and good. However, we need to find the standard deviation. So what we're going to do now is standardize a normal distribution, turn it into using a transformation, turn it into a normal distribution where we know the mean and standard deviation, and then we're going to be able to get the standard deviation as an unknown that we can deal with. So to do this, we turn it into the standard normal distribution, which has mean of 0 and standard deviation of 1. So let z equal x minus 67. Okay, so we minus 67 from every single value, and then we also divide by the standard deviation, and that will give us the 0, 1 squared distribution. So now my 72 is going to become 5 because it's 72 minus 67 over sigma. And my other one, my 62, is actually going to become minus 5 over sigma, although that's actually not going to be important. So do you know what? I'm going to leave it out. But what I can say is that the same property still holds. Probability that z is less than 5 over sigma is going to equal 0.75. Ah, we're in a great place now. We can do inverse normal. So 5 over sigma inverse normal, area of 0.75, standard deviation of 1, mean of 0, because we've transformed it into the standard normal, and we get 0.67448. 67448. Okay, so I just need to times through by sigma, divide by 0.67448, and we're there. It's actually stored in the memory already, so I can just do 5 divided by answer, giving me 7.4130. Or 7.41. Okay, make sure you practice these and situations where you don't know the mean, situations where you don't know both. Well done.